So in our today's class, we are going to study again chapter number 3, circular motion. But now this circular motion is entirely different than that what you studied in before. So before you might be studied that in class 9th, we used to study circular motion. So all of you keep reading. We used to study circular motion, but you might be that studied that it's not a circular motion. You might be used to study that uniform circular motion. Have you heard about it? Yes or no? All of you? So uniform circular motion. This is what we used to study in the class 9th. And we used to calculate the speed of the body, not velocity of the body, which is equals to circumference of a circle divided by time taken to complete the run. That is what 2 pi r by t. So that is what we used to study. Am I right, everyone? Please respond. So if you notice it here, uniform circular motion, what is remains always constant? The speed of the body, speed, that is what is remains constant. The speed is only we used to called as what? Magnitude. Understanding? So magnitude of velocity is remains constant. So that is what we used to say uniform circular motion. So today's class we are going to study that is what. Of course, we can change the velocity by two ways. What is the two ways, guys? I already taught you people. So velocity can be changed by two ways. As it velocity is a vector quantity, so we can change it by what, everybody?
Magnitude direction.
Yes. So we can change it by magnitude, understanding, and also we can change it by changing the direction. Of course, circular motion already we studied. So at every point in the circular motion, the direction of the body is always how it will be acting. If I take here velocity, and if I take where velocity, if I take here velocity, always you can see the force which is acting tangent, the force which is acting towards to the center, that is what centripetal force. So always what is the angle between them? Everybody? Yes, please. At every place, what is the angle? We have done it already, this one. What is the angle between them? At every point, angle equals to how much? The direction of velocity and centripetal force, which is equals to 90. So the work done by centripetal force. What is the work done by centripetal force, everyone? Or work done by tension. If you take, for example, there is a rope and a bob, and it has been continuously revolving in a circular track. So what is the tension? The work done by the tension at every point. What is that, guys? Anybody? Work done by the tension at every point is how much, guys? When the bob is revolving in a particular direction. Always the angle velocity between them at every point, direction of velocity and the tension is 90 degrees. So that what is the work done by the tension? Everybody? Work done by the tension is equals to how much? Work done by tension is equals to always 0. So because the work done is equals to force into displacement into cos theta. So as theta is equals to 90. So cos 90 is equals to how much, guys? 0. So that
Zero.
Fs is equals to what? Work done by the tension, which is equals to what, everyone? Work done by the tension is equals to 0. So now, this is what uniform circular motion, what you studied in the 9th class. Speed of the bodies remains constant. That is what magnitude of the bodies. Magnitude of velocities remains constant. But, today's class, what we are going to see, it is a circular motion. All of you remember? Circular motion. Motion in a vertical circle. Vertical circle. So that is what means the velocity, the magnitude of the velocity is also not remains constant. And this is the most important concept for IIT JEE and as well as NEET. So please remember that. So, and we are going to study the concept called as critical velocity. Critical velocity. Okay. So we'll understand what is the critical velocity and all. Okay. So all of you observe very carefully. Now, this is what we used to say, non-uniform circular motion. So it is not uniform circular motion. What is this, everybody? Non-uniform circular motion means magnitude is also changing, and as well as what is changing? Velocity is also, direction is also changing. So that this is what we used to call as, means a velocity at every point, the magnitude of speed, the magnitude of velocity is also not constant. So that is what is the motion we used to call as what, guys? Everybody? non-uniform motion. That is only we used to call as vertical circular motion. So vertical circular motion is not a uniform motion. It is a what motion, everybody? Please respond. Vertical circular motion is a non-uniform circular motion. Means the magnitude of velocity is not remains constant. Okay. So let us understand this concept very simply. I will make it as simple as possible. I hope you all understand what is our today's target. Are you clear, everybody? Ninth class we will study uniform circular motion. Today's class we are studying non-uniform circular motion. That is what vertical circular motion. So this is the most important and easiest way I'll teach. So try to find it. So let us take one freely suspended bob is hanging. Okay. Now let us, I will explain you with the things. Now all of you observe very carefully. Just have a glance. Every second is very important. From this only we are going to learn. I'll make it very imaginative and very beautifully. Just have a glance and learn properly. That's all. No sound, nothing. You just understand and we will make it. So what is our objective, everybody? We are going to study the what? Dynamics of vertical circular motion. Okay. Now, all of you observe very carefully. This is what a freely suspended bob. Okay. Now, let us imagine just everyone, all of you make it. Later I will make the sound also. Now, I will just hit with a very low amount of force. Now, what this bob will do? Can you tell me? There is a bob whose length, whose string of a length is L. Let me take the length string is L. Now, I just with a small applied force. What this bob will do? Anybody can tell me? This bob will start going till certain distance, certain height, and again it will be started coming, and again it will be go to the same height, and again it will be starting. So it will start doing the periodic motion. That is what we used to call as oscillation. Am I right or wrong, everybody? Please respond. Everyone? Yes, Mr. Rudreswa. If I increase the force, let me take the body is traveling with some other more velocity, force increases, velocity is also increases. Now, if I increase the velocity, some other thing, let me take this point is A. I increase the velocity a little bit more, so that now this bob is reaching to this point, and again it is started moving, and again it is going back to this point, and again it is going in the same thing. Again it is making oscillation. Imagine that if I applied a certain force, which is extremely large, like it is traveling with some velocity, where the body will keep on rising, going and coming again. It will make complete rotation. Do you understand, everybody? What path it will make? Complete rotation means what path it is making? Anybody? It is making what? Complete rotation it is making. What is the path actually? Circular path. Do you all understand, everyone? Yes. So that is the velocity. What velocity we have to give to this bob in such a way that the body has to make complete circular motion. Understanding? Complete circular motion. That is what we are going to see that. Do you understand, everyone? All of you clear? That is the velocity we used to call as what velocity? Critical velocity. Okay. So now observe very carefully now and then I will explain it. Okay. So let's start, everyone. Can you able to hear me?
Yes, sir.
Yeah.
Yes, sir.
Inextensible string of length.
Inextensible string means the length of the string is changing or remains constant. Everybody. Remains? Yes, please. Remains what?
Constant.
The length of the string is remains constant. It is inextensible string. The string length is always remains constant. Spring means it will changes. Am I right or wrong, guys? Spring means it will change or not? Yes, that is the string actually. So it's not the spring, it is the string. So let us see now how it will be taking place. So what is the length of the string? L, and there is a bob whose mass is M. What is the mass of the string, everyone? Whose mass is M. Now all of you observe.
L is fixed to a fixed point O, and its other end is tied to a very small bob of mass M. The bob is given a sudden push at the...
Now see, they are applying with a hammer, they are hitting. There is a certain push. It is not something. So it is creating some velocity. Am I right or wrong, everybody? Yes or no? So Bob is attaining some velocity. Of course, you watch it. Then
the
we'll see.
lowest point, A, in the horizontal direction, so that its velocity is v naught at A. The bob takes a circular path of radius.
Imagine that if I give very low velocity, it will make periodic motion. If I give a certain force, that how much force it is, so that force, the bob will make complete circular motion. All of
L
it. It is
in the
making
vertical
complete
plane.
circular motion. So this motion is only we used to call it as what? Motion in a vertical circle. Motion in a vertical circle. All of you observe.
Let's divide the circular path the bob may take into 4 quadrants around point
All of
O.
you observe. So I'm making into how many coordinates? The circular track. Everyone. How many coordinates? 4 coordinates I'm making. So we all knows that from the origin, this is actually A point. Let me take, and this point is the B point. So we all knows that. Everywhere, what is the angle? Everybody, please respond. What is the angle, guys? So here will become what? Angle 90. And here what is the angle? Everybody, 180. And here what is the angle? 270. And here what is the angle? Of course, 360 means it will come to 0. All of you observe very carefully. Now, if I give a certain force, Mr. Pradosh, see that. If the bob is, for example, here, I have given you very low amount of force. Means, of course, the velocity of the bob is acting here. At the A point, what is the velocity of the bob? At A point, what is the velocity of the bob? V naught. So I have given very, very less amount of force. Do you think that the body will make complete circular rotation? Everybody? Is it possible to make complete circular rotation? All of you? No. So there is a certain velocity I have to create to the body, means certain force has to be exerted on the bob, such a way that that velocity of the body make it complete rotation. Do you understand it? That velocity is called as critical velocity. How much velocity we have to give to the body so that it will make complete rotation. Clear, everybody? So understand it now. So let us make it now. Just watch it. Every point I'll explain. So you have to make it, and we are going to derive that also. Critical velocity now.
0 to 90 degrees.
90. What will happen?
90 to 180 degrees.
180.
180 to 270 degrees.
270,
And 270 to 360 degrees.
That's fine.
Consider the bob at point.
Okay. Now, let us consider the bob is travel at this point. Now you tell me, at this point, what is the direction of velocity? Of course, that the tension in the string is acting upward direction. Am I right, everybody? Please respond. All of you? Yes?
Yeah.
Yes. If the bob is here, there is a force which is acting outward direction. What is the force? We used to call some force which is always acting outward direction, opposite to the tension, which will like an unimaginary force, non-frictional force. What is that called as? Yes, please. Pseudo force, which is equals to how much? We already done it. mv square by
R.
mv square by r. Now here r is equals to something. That is what? Length of the string. What is the length of the string we have been taken, everyone? What is the length of the string we have taken? L. So that I can make it as a this one mv square by L. Is it okay, Pradosh? Rudreswar, understand? Clear? Now, if I take here at this point, can you tell me what is the velocity of the body? Velocity of the body is a tangent. Am I right or wrong? Everybody clear? Please respond. All of you? Yes. So if it is velocity is here, then the angle, it is making an angle from the center. What is the angle it is making? Let me take that angle is how much? All of you. Angle is how much, Ra? Theta.
Yeah.
Angle is how much? Theta. So now if you observe very carefully, if here is the angle is theta, then if you notice it here, always weight of the body at the C above from the ground. Above from the ground means something is acting downward direction. What is that? You all said by this time you should tell me. What is that, everybody?
Wait.
Weight of the body. So now here is the theta means, then here also how much, Rudreshwa? This is also angle is how much?
Theta.
Correct or not? You all should respond so that weight will split into
Yes.
the two components. What is the components? One is x component, another one is y component. So theta. So here what will happen? This will become mg.
Past it.
mg cos theta, and this will become what? You should speak mg sin theta. Okay. So now all of you write the equation. So what will happen, everybody? All of you check it. So tension in the string T is equals to So these two forces are acting. What is the two forces are acting? If I draw the free body diagram, check it. One is a pseudo force, that is what, mv square by L. Another force is what? mg, speak ra, mg cos theta. And the tension is acting upward direction T. So let me draw this one properly so that you all understand. So free body diagram. So you can see that. So
Sir,
let's imagine the
force
body. Yes.
force, sir.
Yes, Rudreswar. The force which
Sir,
is exerting
pseudo-
opposite. Yes, yes. If the
Sir,
body, the
pseudo
force
force
which is
are
equals to
centrifugal, sir.
tension, correct? The force which is equals to tension, correct or not?
Yes, sir.
Yeah, the
That is
centripetal force is equals to
centrifugal.
pseudo force. Do you understand? The force which is trying to pull us outside. Yesterday class also we studied the force which is trying to pull out, which is equals to the centripetal force, correct? Which is equals to mv square by r. Understand?
Yes, sir.
Yeah. So what will happen now? So the force which is acting upward direction, that is what? Tension. And there is a two things which is acting down. One is mv square by r. Another one is mg cos theta. So now tension is equals to mv square by r plus mg. What will happen? Yes, respond. Sorry. Here I have done mistake. So which is equals to centripetal force. So sorry, this is. So what is the mistake here? So tension, both are acting opposite direction. Tension is upward and mg cos theta is downward, which is equals to centripetal force. So T minus, 1 minute. So T minus mg cos theta, which is equals to, what will happen? Centripetal force. So T minus mg cos theta, centripetal force is equals to what? mv square by r. So this is what? Tension. Now tension equals to what will come? Everybody. Of course, we can make it. So tension T is equals to what will happen? Everybody. mv square divided by L. R means L. Plus, we'll write it mg cos theta. So that is what the tension at this point. Do you all understand, everybody? Clear? So when the body, if you imagine the body is here, so the tension exerting on the string, which is equals to how much? Tension exerting on the string is equals to mv square by L plus mg cos theta. So this is the first thing we have derived here. So just observe it carefully and then we'll proceed it. Okay.
And it is tangential to the circular path. Let's draw the free body diagram of the bob at P. At P,
So always weight of the body is acting what direction? Everybody. Weight of the body is acting what direction?
Downward.
Downward direction. So that here theta is same. So whatever the theta is existed here also the theta is same. So now which is equals to, all of you observe. So that's what first we have to imagination is very important, and then if you understand it will be very simple. So in circular motion, we all people knows that every point velocity is tangential to the direction of tension, correct or not? Everywhere 90 degrees. So now if you notice weight of the body as it is went above from the ground, weight of the body is acting downwards. What is the weight of the body? mg. Do you understand, everyone? So mg. So mg means here theta means here also theta. So that force will split into two directions. One is this direction, another one is y component, another one is x component. So what will happen? Here is the theta. Here what will come? mg cos theta.
tension T acts along the radius.
Along the
Gravitational pull mg acts in a vertically downward direction, which can be split into two components.
two components. What is that? Here mg cos theta, and opposite direction what will come? mg sin theta.
One in the radial direction and the other perpendicular to it. Net force acting along the radial direction is T minus mg.
One is upward, another one is downwards, which is equals to what? Which is equals to centripetal force. So T minus mg cos theta, which is equals to centripetal force. What is the centripetal force? mv square by L. So from the tension is equals to what will happen, guys? mv square by L plus mg cos theta. Okay. So that is the tension at these things.
Cos theta. This force along the radial direction is the net centripetal force Fc. But we know that the centripetal force required to keep the mass m moving with tangential speed v in a circular motion of radius L is equal to mv square by
Basically, it is
L.
mv square by
Therefore,
r.
mv square by L is equal to T minus mg cos theta. Hence, tension in the string is mv square by L plus mg cos theta.
Understand everybody? Clear? Pradosh? If you imagine
Yes,
that.
sir.
This is what. So please note it down. Till here you can complete it. Now, if suppose, let us discuss now, all of you observe. If suppose, for example, I have given a certain velocity, V0, let me take the velocity is V0. Now, if I am not giving sufficient velocity, it may reaches to the first coordinate, 90 degrees. After that, as we know, it is a uniform or non-uniform. It is a non-uniform velocity. Now, all of you observe very carefully. When the bobbies keep on rises, if the velocity is not sufficient, so it will goes to certain place where the normal will become zero. Normal will become what? Normal reaction will become what? Everybody. Normal will reaction become zero if you are not giving sufficient input velocity. So at that point, body instead of making the circular path, it will start falling into the something to make it. So that is what we used to. What is this path? Anybody can tell me? We already studied that. It will follow the some other thing. This kind of motion we used to call something. Anybody can tell? Yes, please. It will follow the path called as projectile motion. And then once it will come back to the same coordinate, again it will start moving on the same path. Remember, if you are not giving sufficient velocity, so at a, once it will cross the first coordinate, so after that the velocity will keep on reduces. So at a certain place where normal reaction becomes zero, whenever normal reaction becomes zero, all of you remember, body will take the path. What path it will take? It will take the projectile motion. Understanding? So that is what is exactly happened. That is why we have to give a certain velocity so that the body has to make. That is what critical velocity, so that the body has to make complete circular path rotation. So that is only we are going to see now. So all of you observe very carefully. Any small doubt also, please ask me. Whenever normal reaction becomes zero, body will take what path? Everybody. Body will take into the projectile path, projectile motion. So that is what you have to remember it. Write it next. Observe very carefully.
If the initial velocity of the bob is very small,
so very small, instead of circular motion, it will make what motion? We all knows that. Oscillating. What is that called as? Oscillating rod to and from motion. What is to call? Periodic motion. Understanding? So if the initial velocity is very, very small, it will make oscillatory motion. That is what
it may not be able to achieve angles greater than 90 degrees.
You understand everybody? Is it angle is reaching more than 90 if the initial velocity is very small? All of you speak, guys.
No, sir.
Yes? No. So from the mean position, it may not attain the angle of 90, so that it will keep on making a oscillatory motion. When the initial velocity is very small. When the initial velocity is small, remember.
In which case, it simply traverses back the path it takes. If initial velocity of the bob is greater, it may cross the horizontal line, but will not be able to reach the highest point.
See that? Little bit greater, it will reach us to the what line? This line is called as something. What we used to call everybody? It will reach us to the horizontal line, but it will not reach us to the what line? This line is called as something. Maximum height. Understanding? So vertical point cannot be reached. The velocity of the bob is more, but this velocity is making the bob to reach to the horizontal position, but not the maximum height. So can you tell me what is the maximum height is equals to here? Mr. Rudreswa, girls, what is the maximum height is equals to? This is L and this is also L. So what is the maximum height is equals to? Everyone.
2L.
Yes, please. All of you respond. What is the maximum height is equals to everybody? It is equals to 2L. That is only we can say 2R. Am I right or wrong? Everybody. Boys?
Yes, sir.
Yes,
So now the force is increases, but that force is help the body to reach the horizontal line, but not sufficient to reach the what? Maximum height. Understanding all of you? So that is what. So When the velocity is not sufficient to make the body to reach the maximum height, so at a certain height, after reaching the certain point, the normal reaction becomes zero. If normal reaction becomes zero, body will take a certain path. I told you. What is the path it will take? Everyone, it will take the
Projectile.
projectile path.
Projectile.
You can see.
Point. When the bob progresses into the second quadrant, tension in the
So tension in the string becomes zero. When the tension becomes zero, when the normal is equals to what?